student, we are going to study about magnetic fields due to electric currents. When electric current passing through a conductor, consider a long straight wire carrying a conductor I through it. Consider a conducting wire and the current passing through it is I. Therefore, the current passing through the conductor, the physicist Oersted invented that when the current carrying conductor, the magnetic field is produced around it. Therefore, that magnetic fields are produced around it. Therefore, by scientist Oersted invented that when the current carrying conductor, the magnetic field produced around it. Then Henry, Faraday, they also show what is the relationship for electric field and magnetic field. But Maxwell gives the theoretical work in the relationship between electric and magnetic field. Maxwell distribution, according to the Maxwell distribution, when the charge is in motion, electric current passes through it, means electrons are transported, electrons are in motion. Therefore, the electrons are in motion, electrons are in the rest condition, the study of electrostatics. But when the electrons are in motion, means the current carrying through the conductor, the magnetic field is produced around it. And the relationship between the charge Q, electric field intensity means E vector, electric field intensity, and B vector, it is represented as magnetic field or magnetic induction. Therefore, the strength of electric field and strength of magnetic field, they are when the charge is state condition or the rest condition, therefore the force acting on Fe, force acting on the rest charge, force of electrostatic force, Fe is equal to Q upon Fe, force Q upon Fe is equal to Q upon or E is equal to electric intensity, E is equal to F upon Q, the electrostatic force of attraction per unit base charge. Electrostatic force of attraction per unit base charge, E is equal to F upon Q, therefore F is equal to Q into E. Electric field, Fe, electrostatic force. Fe is equal to Q into E. Fe is represented as electrostatic force or force due to electric field. And another force arise due to magnetic field. The force due to magnetic field, it is represented by Fb is equal to the electrostatic force or the magnetic force produced due to the magnetic field is Q in bracket V vector cross B vector. The force due to magnetic field, in 11th standard we study about Fb is equal to, Fb means force due to magnetic field. Fb is represented as force due to magnetic field. charge is in motion. Charge of charge on electron is minus E. Therefore, that equation can be represented as minus E in bracket V vector cross B vector. But when electrons are in motion, they are oppositely flows through that conductor. Current flows in upward direction, electrons flows in downward direction. Therefore, the both forces, electric force due to electric field and also force due to magnetic field, both forces, they are apply on the conductor. The force due to magnetic field and force due to electric field. The electric current passes through it, means electric current passes through it, therefore electrostatic force. Hence, electric force and magnetic force act on the same conductor. That forces are called as the total force act on it. F is equal to Fe plus Fb. Or Fb is also denoted by Fm, means force due to electric field and force due to magnetic field. Therefore, Fe and Fm means substitute the value of Fe is equal to Q into E plus Fm is equal to magnetic force, Fm is equal to B में represent करा तो magnetic field में represent करा. Fm is equal to Q in bracket V vector cross B vector. Therefore, Q in bracket electric vector. Therefore, Fe plus in bracket V vector cross B vector. And that force is known as force due to electric field and force due to magnetic field. The total force acts on the conductor, then that force is known as Lorentz force. That force is known as Lorentz force. Force due to magnetic field as well as force due to electric field, the sum of both is known as Lorentz force. F is the Lorentz force acting on the conductor. Then that force is known as Lorentz force. If the particle is at rest condition, means the charge is at rest condition. Case first. Charge is at rest. Charge is at rest, therefore there is no velocity of the charge. Charge is at rest condition means velocity vector is equal to 0 vector. Velocity vector is equal to 0 vector. Therefore, V vector is 0. Then their cross product is B vector is not equal to 0, but V vector is 0, therefore their cross product is 0. Means that product is 0. Therefore, F is equal to the total force acting on the charge conductor. Velocity is equal to the force is also 0. F is equal to Q into Q vector cross V cross B. Velocity is at rest condition, therefore V cross B is equal to 0. Therefore, that force, magnetic force is 0. F vector is equal to 0. Only electric charge force act on it. Second condition, if the charge particle is parallel to the magnetic field. If charge particle parallel to B vector. Therefore, the charge particle is parallel to the magnetic field. The magnetic force is the two vectors. If two vectors are parallel to each other, their cross product is 0. Their cross product is 0. Therefore, V vector cross B vector is equal to 0. V vector cross B vector is equal to 0. Therefore, magnetic force is 0. Fm is equal to 0. Magnetic force is 0. Hence, then the charge is, first condition is charge is at stationary means V vector is equal to 0. The force is 0. Fm is equal to 0. And charge particle parallel to the magnetic field. If the charge particle is parallel to the magnetic field, their cross product is V vector cross B vector is equal to 0. Then magnetic force is 0. In both cases, magnetic force is 0. When the charge is at rest condition, there is no magnetic field, therefore magnetic force is not created. Hence, Fm is equal to 0. And second condition, if the charge particle is parallel to the magnetic field, then their cross product is 0. If the two vectors are parallel to each other, their cross product is 0. Therefore, Fm is equal to 0. That total force is known as force due to electric field and force due to magnetic field. That total force is known as Lorentz force. When the charge particle or when the current carrying through the conductor, Lorentz force acts on it. Because of due to the motion of the charge, the magnetic field produced around it and electric current flows through it, means electric field as well as magnetic field act on the conductor. Therefore, Lorentz force acts on it. The V vector and B vector, they are represented by V vector and B vector, and their cross product is V vector cross B vector. Their cross product is perpendicular to the plane containing the V vector and B vector. The cross product of both vectors means V vector and B vector are mutually perpendicular to each other, but the third vector, remaining third vector, is the cross product of the two vectors is the perpendicular to the plane containing V vector and B vector. According to the right hand thumb rule, suppose this is a conductor and they are held in my hand. The four fingers are curled around it and the magnetic fields around it. Therefore, my thumb shows that current carrying through the conductor, and that curled finger gives the direction of magnetic field. The magnetic field produced around it. Current carrying through the conductor, this represents magnetic field. Therefore, the straight conductor, force acting on the conductor, magnetic field, current carrying field I, and velocity of the particle. Velocity of the particle means velocity is along the downward direction. Velocity of the particle. Therefore, that gives a Lorentz force acts on the conductor due to electric field